This is Professor Bittinger, and we are on video 2 for Chapter 1. The 5 root causes of our environmental problems are depicted on the screen in front of you. I will go over these briefly today, but please recognize we will go over each of these in much more detail in later lectures. In terms of population growth, it makes sense that more people on Earth means more resources being needed to supply our daily needs for life, including water as one, as well as our demand for oil and coal for electricity. In addition, more people equals the more waste being generated as a result of the consumption of goods. It's estimated that the average American consumes about 30 times the amount of resources than the average person living in India, as well as 100 times the amount of resources consumed by the average person living in the world's poorest countries. In fact, if all 7.3 billion people on this earth lived like we do here in the US in terms of resource consumption, it is estimated that we would need 5 planet Earths in order to sustain the rate of resource use. The second category is unsustainable resource use, and 3 quick examples of this would be overfishing and removing fish at a higher rate than that which can be replenished by the reproduction of the fish in their natural environment. A second unsustainable resource use example is overdrawing our water resources from rivers and streams, and we will talk more about the Colorado River, the Aral Sea, and Lake Chad in a later video lecture. And then a third example is what's depicted on the screen in front of you, deforestation via clear cutting, which has a much greater impact as opposed to if we use a sustainable approach known as selective cutting. The third category is poverty, and poverty is defined as people being unable to fulfill their basic needs for adequate food, water, and shelter, as well as having access to adequate health care and education. According to the World Bank, 900 million people live in extreme poverty of less than $1.25 a day. This is 4 times greater than the U.S. population. The World Bank also estimates that 1 out of every 3 people, or 2.6 billion people, struggle to live on less than $2.25 a day. Could you do this? Think about your lifestyle and the choices that you make each day and the monies that are involved with supporting those choices. Could you live on less than $2.25 a day? In these poverty areas, people are desperate for short-term survival. These individuals do not have the luxury of worrying about long-term environmental quality. Thus, they can collectively cause impact to forests, deplete fisheries, and also deplete wildlife populations in order to just survive. The fourth category is excluding environmental costs from market prices. The market price is the direct price that we pay for a product or service, and it usually does not include all the indirect or external costs of harm to the environment and human health that is associated with the production and use of that product. Such costs are called hidden costs. So for example, if we buy a car, the price includes the direct or internal costs of raw materials, labor, shipping, and a markup for dealer profit. In operating the car, we pay additional direct costs for gas, maintenance, repairs, and insurance. However, the hidden costs of manufacturing and using the car, such as extracting oil for the refinement of gasoline, or car exhaust impacting air quality and climate change, actually results in other people in society paying for these hidden costs. The hidden costs are paid for in the form of poorer health, higher expenses for health care or insurance, higher taxes for pollution control, and sometimes the cost to restore the degraded environments. Including these harmful external costs into the market price of goods is called full cost pricing. Basically, full cost pricing includes the harmful environmental health costs and the cost of the good or the product being sold. It is believed by some economists that full cost pricing would reduce resource waste, reduce pollution and environmental degradation, and it would improve human health by encouraging companies to invent more resource efficient and less polluting methods of production. It would also enable consumers to be informed in their decisions about what goods and services they are buying. For example, if the harmful environmental and health costs of coal mining and burning coal to produce electricity were included in the market prices of coal, coal would actually be more expensive and less likely to be used. In fact, it would be more likely to be replaced by less environmentally harmful resources such as solar or wind power. But currently coal is cheap, and that's because we do not yet incorporate the concept of full cost pricing in the price of coal. The last category is trying to manage nature without knowing enough about it. We'll dig into this in more detail, but two examples that I can give you is draining of our wetlands in order to develop the land for housing developments or business and industry. When we remove wetlands from the surrounding area within a watershed, it changes the absorption of rainfall in that watershed. The result is we have more floods of higher frequency and larger magnitude. So we're finding that our draining of wetlands is causing a ripple effect into the flooding problems that we experience in largely developed communities. Another example of this would be engineering design and trying to control the flow of rivers and building levees and dams. We are now finding that our approach to try to manage this flow of water in a river is actually causing more harmful impact upstream during large rain events. These are just two examples of trying to manage nature without knowing enough about it. The definition of sustainability is on your screen and in your textbook. We will be utilizing this concept of sustainability throughout the course. It's basically the ability of ecosystems and human cultural systems to survive, flourish, and adapt together to constantly changing environments over long periods of time. So what are the goals of environmental science? Well, basically, to learn how life on Earth has survived and thrived in the past, to understand how we can interact with the environment, and to find ways to deal with environmental problems and live more sustainably. Sustainability has some key components. The first one is having an understanding of natural capital. Natural capital is typically broken into two subcategories: natural resources and ecosystem services, and I'll discuss those further in some follow-up slides. How do we as humans degrade natural capital? By using renewable resources faster than nature can restore them, and by overloading natural resources with pollution and waste. And we'll go into more examples of those as well. So this is a diagram that depicts natural capital. In the blue, the natural resources are being highlighted. For example, air, water, renewable energy such as sun, the wind, and water flow, soil, non-renewable energy such as fossil fuels, non-renewable minerals such as iron and sand, land, and biodiversity. Those are all considered natural resources. In orange, you have ecosystem services. These are the services that the ecosystem provides in order to sustain species that live within that ecosystem, including we as humans. Air purification, climate control, the ozone layer providing a protective layer from ultraviolet light, water purification, waste treatment. In fact, wetlands are a natural waste treatment system that do a good job at purifying water. Population control. This is in relation to interaction of species from a predator-prey scenario, not specific to humans. Pest control, food production, nutrient cycling, and soil renewal. So this figure, it's important for you to understand what's the difference between natural resources and ecosystem services, and the two of these combined constitute what we say is natural capital. This diagram depicts ways in which we have degraded natural capital. As you can see here, air pollution, soil erosion, declining ocean fisheries, water pollution, decreased wildlife habitat, shrinking forests, species becoming threatened or endangered or maybe even extinct. These are all various examples of how we can degrade natural capital within an ecosystem. Your textbook calls out 3 different types of natural resource categories. The first is inexhaustible resources, which are considered to be renewed continuously, and examples of that are solar energy, wind, tide, and flowing water. Renewable resources are ones that can be replenished rapidly, ranging from hours to decades, and the items that fall in this category include fresh water, clean air, topsoil, fish, and forest as examples. Non-renewable resources have a fixed quantity in the environment and do not have a replenishment rate as a result of that. And 3 that fall under this category of non-renewable resources are energy, metallic minerals, and non-metallic minerals. A key term that I would like you to know associated with natural resources is sustainable yield. Sustainable yield is defined as the highest rate that we can use a renewable resource indefinitely without impacting its perpetual availability. In other words, we utilize the resource at a rate at which is less than its ability to replenish itself. Your book highlights a concept known as the tragedy of the commons. It's basically environmental degradation due to the overuse of resources as well as shared resources. And it comes from the mindset of individuals believing that, hey, the little bit that I use or pollute is not enough to matter. And anyway, it's a renewable resource. Unfortunately, this is not a sustainable mindset in regards to managing our resources effectively. Finally, I just want to highlight a key term again for you, and that is sustainable yield. It is simply the highest use of a resource that we can do while maintaining that supply. This specifically applies to renewable resources because they have a replenishment rate, but not to non-renewable resources. So again, please be sure to understand the concept of sustainable yield. And this concludes our second video. Please click on the next video to continue.